Hey everyone, welcome to my channel. Aditya here. So, we'll continue our AWS comprehensive course. In this session, we are going to cover Lambda, configuration, and performance. So, we'll start with configuration. Okay, so when you are creating a Lambda function, we are directly creating the Lambda function and we are testing the code, right? We are not going in depth in the configuration section. We'll see what are the other configurations. So we see a few configurations, right? And we'll see what are the other configurations we need to cover, right? We missed or we need to cover or we need to remember. Okay, the first one is the Lambda can scale from 128 MB to 10 GB RAM. Okay, so usually when you are creating a Lambda, right, you have an option to select the Lambda's RAM. So what is the RAM length or RAM size? So it could be around 128 MB or it could be 10 GB. Okay, so you can increase your Lambda's RAM from 128 MB to 10 GB in 1 MB sessions. For example, from 128 MB, you can increase to 129 MB, 130 MB, like that up to 10 GB. Okay, so why we need to increase RAM, right? So why we need to increase RAM? So increasing the RAM, what was the benefit for us? So the thing is, the answer is, unlike EC2, Lambda doesn't have direct access to increase the vCPUs. So by increasing RAM, we can indirectly increasing the vCPUs also. Okay, so Lambda usually don't have an option to add vCPUs. We know Lambda is serverless, but serverless is in your perspective. But behind the scenes, Lambda uses an instance, EC2 instance only, right? A server only. That server should have RAM and it has vCPUs. Okay. But the configuration section of Lambda, you don't have directly privilege to edit your vCPUs. You have only a privilege to edit RAM. So if you increase your RAM, right, indirectly you are increasing your vCPUs also. Okay. So remember this point. So one more point you have to remember is if the RAM reaches 1792 MB, that means Lambda utilizing one full vCPU. So in Lambda, one full vCPU's capacity is 1792 MB. Okay. So after, right, if your Lambda reaches 1792 MB, then, right, it will add one more vCPU. Okay, it will add one more vCPU. For example, you increased your RAM from 1792 MB to, for example, 2000 MB. Okay, so if you increase like that, what Lambda will do is behind the scenes, it will add one more vCPU to your Lambda. Okay, so the better approach to use Lambda is multi-threading. So whenever you are using Lambda, and if you want to utilize more RAM or more vCPU, right, then you remember always implement multi-threading in your Lambdas for optimal performance. Okay, so that we can utilize the vCPUs in an optimal manner. Okay, so the next point is if we need to perform more computational task in your Lambda, then we need to increase Lambda. So if we need to perform more computational tasks in our Lambda, then we need to increase the RAM. So there is no other option. Okay, so if you increase your RAM, indirectly it will increase your CPUs. So if CPU is increased, you can do your computational task better. Okay, so that was one advantage. And with respect to the timeouts, right? Lambda by default has 3 seconds timeout. So if you didn't set any timeout, by default Lambda takes 3 seconds as its timeout. And if you want to increase the value, we can increase up to 900 seconds, that is 15 minutes. So the maximum value you can set for a Lambda timeout is 15 minutes and the minimum or default is 3 seconds. So you can decrease the default timeout, but it's ideal to keep 3 seconds, or if you have more computational task, your Lambda will run more than 15 or 10 minutes, right? In that case, you use 900 seconds as your highest value. Okay, so these are all the configurations, right? These are all the configurations part of Lambda. Okay, so these configurations we haven't covered in the previous sessions. Previous sessions we didn't increase the RAM or we didn't look at the timeouts, right? But we have seen the important configurations. By using these configurations, we can improve the performance of Lambda also. Okay, so with respect to configurations, these are the topics we missed. And the other one is with respect to performance, right? With respect to performance, we need to discuss these points. The first point is Lambda execution context. So always remember about this Lambda execution context, which is very important concept. Okay, so whenever you invoke a Lambda, right? Whenever you invoke a Lambda function, right? Temporary a runtime environment will be created, right? For you, a runtime environment will be created. Okay, in that runtime environment, we can initialize any external dependencies of your code. For example, if you start your Lambda function, right, and if you want to store the database connections or HTTP calls, REST API connections, or any SDK client connections, you can use this Lambda execution context. Okay, so in this context, what it will do is it temporarily stores all these connection details, and whenever your handler code, right, in Lambda function we have handler, right, whenever your handler code calls these external dependency connections, for example, database connection or REST API connection or your SDK clients, it will fetch those information into the handler code. Okay, this execution context is helpful in different scenarios. So, example to initialize external DB connections, HTTP connections, and SDK client connections. Okay, the execution context usually don't get removed after the Lambda execution completion. It will be available sometime for the next function invocation. So this was a very good point. Okay. For example, you invoke three lambdas at a time. Okay. The first lambda with a small interval of time. Okay. You executed or you invoke a lambda three times with small interval gaps. Okay. And if you store your database connections, HTTP connections, and SDK client connections in this execution context, what will happen, right? If the first lambda function executes and it completes its execution, and meanwhile the second lambda function also started executing, right? Instead of creating these DB connections again, the other lambda function also start using the this DB connection which was created earlier. Okay, so this execution context is like shareable for different lambda functions. So it's not different lambda functions, it's like same lambda function but different invocation of the same lambda function. Okay, so keep in mind, if you create your external dependencies connections or objects, right, in your execution context, it will be shareable for this different invocations, so that you will get, right, your performance will be increased because you don't need to wait for a DB connection to establish next time. It will use the previous established connection again. Okay, for example, if you invoke the same lambda for 5 times at same interval time, okay, this context will be reused among these lambda invocations. The same point, right, whatever I explained earlier, we are going to reuse the DB connection, HTTP connection, or SDK client connections, right? These are the external dependencies of your code. You can initialize those and reuse those among the different invocations of the same lambda function. Okay, so the next point is, right, you need to consider this code. Okay, this is the wrong code. So whatever I told, right, the execution context which was resides in after or before the handler code. For example, you have this definition lambda handler. This is your actual lambda function. But if you want to define, right, any external dependencies, right, you have to define before the handler. So if you define before the handler, for example, in the line number 4, right, those will go in the execution context. So this particular place will be treated as an execution context, lambda execution context. So here it is a wrong example. This is a wrong code, right, where every invocation of the lambda will get this environmental variable, and also it will use this request.get, right? This is an API call. Request.get this URL will give you a response, and we are printing that response here. But here every time you are establishing an API connection. So every time you are calling this get URL. But some cases you need to call your API multiple times, right? But with respect to DB connection, for example, here you have DB connections. With respect to DB connections, sometimes you don't want to call again, right? So the DB connection establishment you need at only once. For example, here I'm fetching the user URL pass from the environment variables, and here I'm creating an MyDB instance, that is the DB connection into this MyDB instance. Okay, so but right, this handler will be executed for every invocation of the same lambda. So for example, if I invoke five times this code will be executed. And for example, this API call will take, maybe it will take 5 minutes, right? Our code needs to wait for 5 minutes for the first invocation. And for the second invocation also, it has to wait 5 minutes. Third invocation also, it has to wait 5 minutes. Same applies for the DB connections. Okay. So for better performance, you should go for this approach. So if you see this approach, right, here we have our handler here, right? Previously the handler at line number 5, but we moved our handler to line number 20, and we have written all the dependency connections. For example, here we are getting an API URL and also are getting a response from this get URL. Okay, so we are storing here in this execution context. So this is the execution context. Even DB connection also you are establishing inside your execution context. So that this first invocation anyway it will take 5 minutes for establishing all this information, and after that it will invoke this handler. And if the second invocation of the same lambda, right, will reuse this execution context instead of again creating this value. Okay, it won't again create, right? It won't again create this or establish this DB connection or get the information from this get URL. Instead of that, it will reuse the existing one from the execution context, lambda execution context. So this is the right approach, right? So the one which is at your right is the right approach, and which is at the left is wrong approach, because here every time you have to get the URL and establish a DB connection. Okay. So keep in mind you have to follow this approach for the better and better performance of your lambda. Okay. And the final point is temporary file location versus persistent file location. So when we need temporary file location, when we need persistent file location, and why we need this temporary file location and persistent file location. For example, if you are using Lambda, you are doing some processing of your code, right? And what if processing of your code requires to download some file into some external or temporary storage, and again and apply operations on it, process them. Okay, process them. So that is one. Or even you can store them in temporary file location or persistent file location. It's your choice. Okay. So the use case here is you want to execute your code in your Lambda. Okay. You want to execute your code in your Lambda, and which depends on some other file. Okay. You want to download that file into some temporary location or some location, right? And apply your logic on that file. Or you want to write some file to some location. Okay. In that cases, you need a file location. Whether it's a temporary file location or persistent file location, it was changed based on your requirement. Okay. But if you need a temporary file location, okay, or if you want to write or download a file to a temporary location during the Lambda execution, then we can use /tmp location or space, location or space available in Lambda. So in Lambda, we have an path. So that path is called /tmp. So if you write a file into /tmp, it will store in the temporary location for your Lambda. So you can download some files into the TMP and choose while your Lambda executing the code, or you can write some files to the temporary location, right? You can use that space for your processing purposes based on your requirements and use cases. Okay. So Lambda provides up to 10 GB of disk space in /tmp location. So this temporary location, right? We are now discussing about only temporary location. So temporary file location should have 10 GB of disk space. So you can utilize the disk space for your processing purposes. And one more advantage of using /temporary space was if your Lambda got invoked multiple times and the first Lambda was stopped due to some reason, The second one can able to pick the same file from this last TMP and proceed further processing. So if you see this TMP, it is similar to our Lambda execution context. Okay, so if the Lambda is already set up the execution context, right, it can reuse the same DB connections, right? In the same way, if the first Lambda is writing something into the TMP and it got stopped due to some reason, and immediately the second Lambda is executing, right? It is here the second Lambda means the second invocation of the same Lambda. Okay, and this Lambda can continue from the place where the first Lambda fails. Okay, so it will read the same file from the TMP location. So this is also, this location also is a shareable location among different instances of the same Lambda. So it can use this TMP location and take the file which was written by the previous Lambda and it will process again. Okay, so that was one more advantage. And this will allow us to checkpoint the failures and restart where we stopped. For example, you have failed at the first invocation, and in the second invocation, you will start from the failure point and you can restart from the place where you stopped. Okay, so that is one of the advantage of using the slash TMP. Now, regarding the persistent storage, right? Persistent file location, it was advisable to use S3 buckets to store the data. So you can use some S3 bucket to read the file and write the file. If you want to persist the data, right? If you want to persist the file, then you can go with S3 buckets. Okay, so that's it about the theory part. We'll meet in the hands-on section. Okay, so now we will start our hands-on session. So whatever we have discussed in the theory part, right, the configuration and performance, we're going to put in action now. So here I'm going to open my Lambda function. So I'm opening my Lambda from the recently visited list. And if you didn't see Lambda here, just go into the search bar and type Lambda. And when we get this Lambda, right, just right click and open in the new tab. Okay. So here I have my test Lambda. So I am going to use this test Lambda. So this is our Lambda function. So as we discussed, right, in our theory session where we discussed about the first point is configuration. Okay, so we need to go to the configuration section here and go to configuration. In the general configuration itself, if you observe, you have your memory. So memory is nothing but your RAM and your FML storage and also your timeout. Okay, we don't have access to do this and we have only access to increase our memory and timeout. Okay, so what I'm going to do is I'm going to edit this, and here, right, you can able to see I can able to increase the memory and FML storage. You can configure up to 10. Yeah, this is for this last TMP, right? As we discussed, this FML storage is for slash TMP folder. So you can increase up to the 10 GB. So here it's mentioned you can increase up to the 10 GB. And also you can increase your memory up to 128 MB to 10240 MB, that is 10 GB. So your memory also you can increase up to 10 GB. So how much memory you increase, that much of amount you have to pay to your Lambda function. So just keep in mind, if you increase the memory, right, it is by in the behind the scenes, right, in the behind the scenes it is increasing your CPU also, powerful CPUs also, right? So if it increases the CPUs, then you will be charged more than previous settings, right? This is default settings which charge less. Even FML storage also you will get charged, right? You will increase up to the 10 MB. Okay, and the next one is timeout. So timeout here by default set to 3 seconds as I explained earlier, right, in our theory section. So these are the configurations, right? You can change those. So as of now I'm keeping as it is and clicking on save. Okay, so now timeout is 3 seconds, right? So to demonstrate that, right, how the timeout it works, we have to go to the code. So I came back to the code now, right? I have this code for reference. So what I'm going to do is I'm going to remove these things. So I have a plain lambda function and which will return some value from the environment. So get env, and I will call this as URL. We'll get an URL and we are returning that URL. That's it. Okay, this is our code. And now, right, here we have set up one environmental variable and we are saying that URL. But where we need to set the environmental variables. That is also important, right? How you can pass environmental variables to your Lambda function. I think we have covered the environmental variable in the previous sessions, right? So fine, but I am going to show you again. Go to configuration and go to this environmental variable section and edit here and add a new environmental variable, that is URL. And we can say just simply give some value. So I'm giving my name Aditya and saving it. Okay, so our code can get the URL now because we have added that URL in our environmental variables. Okay, I'm deploying it and all the new changes now got deployed. Now what I'm going to do is I'm going to import one more package. I'm going to import one more package, that is import time. Okay, and by using this time, what we are going to do is we are going to use this time dot sleep and provide 2. So we are saying sleep for 2 seconds. I am deploying these changes now and we'll see how this Lambda function works. So click on text. For that we need to create an test event. So I'm creating one sample event and saving it and test. Okay, now the execution got started and you can see our response is Aditya. We got that URL from the environmental variables, and also here you can see the total duration. It took 2000 milliseconds, right? So 2000 is the 2 seconds which we give the time, and usually the Lambda function took 3.43 milliseconds. That's it, because we have already given 2 seconds time sleep, right? So that's why it took 2000 extra milliseconds. Okay, and we know by default we have set 3 seconds as timeout. So what happens if I give more than 3 seconds? So I'm going to Lambda and I'm going to increment this to 5 seconds. So if I say 5 seconds, right, which is more than 3 seconds, we'll see Lambda fails or not. So I'm deploying this new change and I'm going to test this. So we need to wait for the 5 seconds, right? 1, 2, 3. And since it failed at 3 seconds itself because it reached the timeout. Okay, so the task got timed out after 3.01 seconds because we have set the timeout as 3 seconds. But our code is running 5 5 seconds, right? Within 3 seconds itself, our Lambda function got failed. Now, if you want to increase your timeout, right, you have to go to your configuration and general configuration and go to edit, and here increase your timeout to 10 seconds or like that. Okay, and save. So we have updated our Lambda timeout to 10 seconds. And come to your code now. Okay, and now try to test your Lambda function. So I'm going to test my Lambda function. Now you can see 1, 2, 3, 4, 5, and our Lambda function got successfully completed. Right, we got the response successfully, and also you need to see the duration it took is 5000 seconds milliseconds, and 3.28 milliseconds is the actual execution of your Lambda, but 5000 is the 5 seconds we have added the sleep, right? So that is it. Okay, so this is how the timeout works. Okay, now when it comes to the performance, right, when it comes to the performance, as I mentioned, we need to define all our external dependency code in this execution context. So whenever I'm typing, right, this is considered as execution context. Okay, which is not inside the handler. Whatever which is outside the handler, it's an execution context. Okay, for example, I have a method called call weather API. Okay, so this method, right, this method, what this method will do is it will call the weather API. So we can say here time dot sleep 5 seconds or 6 seconds. Okay, and here remove this, and instead of that call weather API like this. So now what we are going to do is we are sorry, here we need to add definition also because it's a function. Yeah, def, yeah. So this is an API. So we are calling the API. So instead I am added the timeout because so this call whether API took 6 seconds to return some response. Okay, so that's why I added some 6 seconds. So this is for simulating the real world scenario, but this is not a real world scenario. Okay, so whenever we're calling this method, right? This is internally calling an API. Imagine that like that. But in this example, we are just sleeping for 6 seconds. Okay, so again, I'm going to test this. So yeah, if I forgot to deploy the changes, so what I will do is first let it complete. I will go to Lambda function and deploy my changes again. And now the new changes got deployed properly. Now I'm going to test it. Click on this test. Obviously, it will took 6 seconds to complete, right? By 6. Now you can see duration took 0.24 or 6004.24 milliseconds. Even if I click on second time, it will again took 6 seconds only. So 4, 5, 6. Okay, now you may wonder, right, how to improve this performance. So to improve that performance, right, here I call this weather API inside the Lambda handler. But what I have explained you are in the theory session, right, we need to call in the execution context. So whatever you define outside the Lambda handler, whatever you define outside the Lambda handler could be treated as within the execution context. So instead of calling inside the Lambda handler, call from this execution context. Now deploy your new changes. Okay, deploy your new changes and now test your Lambda. So here initially it took 6 seconds only. Look 1, 2, 3, 4, 5, 6. So it took total 2.31 is the total Lambda execution and initialization section duration is 6 seconds. And again quickly I test this Lambda and if you see it completed within very less time. Look, it took 5.07 milliseconds. Again I will test. It took very less, right? So why it is taking less time? Because in the first invocation it took 6 seconds because it is actually calling this call whether to API method. But in the next invocation it is not going to call this. Instead of it is going to reuse the previous execution context, right? So that it is not going to call this method in the next execution. So that it saved you the 6 seconds, right? So like that you define all your DB initializations, HTTP calls, SDK client calls in this execution context to provide performance to your Lambda function. Okay, so I hope you understand what is the importance of the execution context and also how to increase your RAM and indirectly how it increases your CPU and also the TMP storage and all. Okay, and also timeouts. Okay. Yeah, thanks for watching my video. If you like my video, like, share, and subscribe. And let me know in the comments if you want to learn more concepts. And I will try to incorporate those. Thank you and bye.